Hello everyone, this is the trigonometry crash course. Basically, before we begin, I want you to know something important. You must know at least 1% of all the topics, because I will be not explaining anything, just giving you cheat codes of how to do it faster. Okay? So, what I want you to remember is firstly, the ASTC, right? This means all positive, sine positive, tan positive, cosine positive. The 180 plus minus problem, you can fix it like this: 180 minus, 180 plus, 360 minus. Right, so I'm going to solve a question I have, right? Question for you guys, a range math question. So let's go ahead and solve it. So we have 2 cosine 3x is equals to cotangent of 3x. Range is 0 to x 2. Before I solve this, I want you to solve it yourself. And this is a very interesting math. I'll explain in a sec why. Because I'll show you why this is interesting. So let's solve it. 3, 2, 1. Firstly, I want you to think of the more complicated side, which is cotangent. Cotangent is 1 over tan. It's 1 over tan. If you're wondering, I don't know identities, that's a problem for you guys. We can keep 4 ranges mostly. Just to remember, the most basic of identities is that tan is just sine by cosine. All inverse, I have something here of the inverse thing. I have to find it somewhere here. I have it somewhere in here. I have to look for it. Oh, I don't have it. Nice. Okay, cool. So basically, if you look at all the inverse ones, we have secant, cotangent, and cosecant. Take the third letter, C, this is T, this is S. This is inverse sine, inverse cosine, inverse tan, because the third letter is corresponding to what's being inversed. So that's a nice little trick if you don't know. So cotangent is 1 over tan. 1 over tan is just this flipped, right? So we write this as cosine 3x by sine 3x. This is a very important thing I want you to do, right? I want you to break it down to the most simplest of forms. This is a very important thing I want you to do. Remember to always break it down in the most simplest form. I'll explain why this is important again in a sec. So we'll bring it to the side. This will be multiplied. So it'll be 2 cosine 3x multiplied by sine 3x, okay, is minus cosine 3x, bringing everything to that one side, equals to 0. So we can take cosine as our common, cosine 3x. We will be left with 2 sine 3x minus 1 is equal to 0. So we'll be left with 2 solutions. We will have one is cosine 3x equals to 0. That's 1. And the second one we'll have is 2 sine 3x minus 1 is equals to 0. So of course we can't directly take inverse. It's 3x here as well. I can also make this one a little more nicer by just bringing the 1 to the other side. Right? This looks much nicer. So we have to multiply this with 3. Let me just remove this now. We don't need this. So just remove it. This. So we multiplied with 3. 3x 270. Right, so we have a range of 270, okay? So the thing that is important here is that let's bring this new range down, I think. So just bring it down. Just keep it right here. Now we are allowed to take the inverse. So let's take the inverse over here. So let's take this one's inverse first. So 3x is equals to cosine inverse of 0. Cosine inverse of 0 is, in degrees by the way, is 90. So 3x is equals to 90. Cosine, you'll notice, is positive. So in the ASTC, cosine is positive on the fourth and the first. That means we'll have 90 as it is. We'll also have the fourth quadrant, which is, if you remember in the pattern, which is plus, not minus, which is plus, minus, plus, minus. This means positive, 180 minus that value, 180 plus, 360 minus. So we have 90 and 360 minus 90. 360 minus 90 is 270. So we have 90 comma 270. Now x is that divided by 3, so 90 divided by 3 is 30. So we have 30 comma, then 270 divided by 3, we have 90. We're not done yet. We still have the other side, which is the sine one. So the sine becomes sine 3x equals to half. 3x is sine inverse of half. So sine inverse of half is 30. So let's move this a little. This is coming in the way. Let's just move this. So let's just this whole thing. It's inside. Right. So now this should be much easier. Right. So 3 sine. Right. So 3x is equals to 30. So sine positive is in the second and the first quadrant. So we will have 30 as it is. And second quadrant is minus. So it's going to be 180 minus 30. Right. So 3x is equals to 30 comma 180 minus 30. 180 minus 30, which is 150. 150. So we divide both by 2. 30 divided by 3 is 10. And this is 50. Now I'm going to have it all in ascending order. 10, comma 30, comma 50, comma 90. And that is our value and our answer. Now this is important. I want you to keep this in mind. Remember when I said when solving this type of stuff to bring it and break it down in the most simplest of form. The reason why is when you don't break it down in simplest form, I mean, you may think, why didn't I just keep this as 1 over tan and bring it to this side? The 3x and 3x will cancel out. Let me show you this. This is another possible way of doing the math, right? There's nothing wrong. There's no process mistake. You notice that I just did this inverse, right? As it is, I brought it here, cut, I'm left with one of the solution, right? I'm left with one of the solution. And my answer is this. And I'm not wrong, I'm partially correct, but I failed to notice that there are 2 other solutions. Now, this happened because, firstly, I didn't simplify to the most basic of form. When you simplify stuff this simple, like when you want to do this, you want to break it down to the most simplest of form. Like 1 over tan can be broken down even more. So when I did that, it resulted in me getting 2 solutions, right here, as you can see, 2 solutions, which gave me the other missing answers, which was the 30 and the 90. This one and this one were the only 2 missing answers. So when doing these maths, always simplify to the lowest form, because this one single thing where you don't break this is what makes you go from losing no mark to losing a lot of marks. So keep that in mind. So now we did that little tricky math. Let me just quickly clear my tabs. It's very loud. Now let's work on radian. So radian. So what is radian? Radian is any math pi. How do you know when you're doing these types of range type, this maths, it's in radians? Mostly, they'll mention it, but a big hint you can use is that the range always has some pi written on it. So let's do a question with it. Funnily enough, there is one right after the one I just showed, the tricky one, which was, let me just use white ink, I think, rather than red. Secant y plus pi by 2 is equals to negative 2. For 0 less than equals to y less than equals to pi. So what's this? Firstly, we have to break secant down to the lowest of forms. Secant, c, so it's 1 over cosine. So it's 1 over cosine of y plus pi by 2. Alright. The thing about last time and this time is different is that I can't break this 1 over cosine into any more simpler forms. So, firstly, go to your calculator and change your gradients. If you don't know how to do that, click on Shift, then Mode, and then if I'm using the 911ES calculator, right? So, if you're using the 991ES, then it's Shift, right? It's Shift Mode. So you click on the Shift button, you then click Mode, and then choose 4, which has like 4 rad written on it. That's what you have to choose to change the radians. So let's go there. So I'm in radians now. So that's good because if you keep it in degrees, the math will be wrong, very wrong. So now let's bring this to here. This is so to write nicely, it becomes minus 2 cosine of y plus pi by 2 is equals to 1. We can write this down as cosine y plus pi by 2 as 1 by negative half. We're not allowed to take any values so far because the range. So we have to add pi by 2. So we have to add pi by 2 to everything. So it becomes pi by 2 less than equals to y plus pi by 2 less than equals to pi by 2 plus pi, which gives us 3 by 2 pi. So 3 by 2 pi. So let's do that right now, 3 by 2 pi. So let's go here. Now we can take the inverse. Let me just bring this range away. This range here. So bring it down here for convenience. So we can take the inverse now. So let's take the inverse of y plus. Wait. Okay, so this is what we have. So y plus pi by 2 gives us cosine of inverse cosine of half. Remember to always ignore the negative sign for now. So cosine of half. It's 1 by 3 pi. So we get 1 by 3 pi. This is cosine is negative, so if we pull out the ASTC, there it is. ASTC. So let's just pull it all the way over here. you notice that we have cosine is negative. Cosine negative means anything but the first and the last. So it's the second and third quadrant, which is 180 minus that value, 180 plus. So we can't just say 181 whatever. You have to remember this. All is all whatever. 180 is actually just pi. Okay, 180 is equals to pi. Remember that. And in radians. And 360 is 2 pi. So yeah. So we will be instead subtracting it and adding it with 2 pi. So pi plus 1 by 3 pi, and pi minus 1 by 3 pi. So what we have, we get pi plus 1 by 3 pi, 4 by 3 pi, so we have 4 by 3 pi, comma, pi 2 by 3 pi. Right, 2 by 3 pi. 2 by 3 pi. Right now, what we have to do is go ahead and solve for x. X is y plus pi by 2, so y plus pi by 2 is equals to this. So y is just subtracting pi by 2 from this, so 4 by 3 pi minus pi by 2, pi by 2, and 2 by 3 pi minus pi by 2. 4 by 3 pi minus pi by 2. We get 5 pi by 6, so we are right with the first answer. So the second one should automatically be also right, 5 pi by 6. And the other one is 2 by 3 pi, right? Pi by 6. And we get the second one is pi by 6. And that's the answer. Pretty much. That's radians. Right. Now we're done with this. Okay? Done with this. It's time for us to touch identities. I will, unfortunately, because this is a very lengthy topic, I have to break it down in 2 parts. I'll break down first half of identities in today's video. I'll go with the more basic identities. And in the next video, I will touch the second half of identities. And I'll finish it off with the graph drawings. Today will be like the first half of identities. But for your challenge, I'm going to give you a hard one, right? A hard challenge math for you guys to solve. Because I want to see what you guys can do, right? I want you guys to do this one. This one's a really tricky looking one. This one's really annoying. Let's see how you guys can do it. This will be your sort of like test type shit. Whatever you call it. It's secant 2 theta minus tan 2 theta divided by cosecant 2 theta. This is equals to root 3 by 2. Our range means 0 to 180. So, once you solve this, this is your sort of hard to test math. And if you're wondering what the answers are, it's going to give you the answers if you want to match them. They're 15 and 165. That's your answers. This is your sort of test work, okay? If you're wondering how and where can I solve this, I'm going to make a Discord server, alright? And I'm just going to have it for you guys to basically ask me any general questions, and I'll just try my best to solve them. Alright? I'll try my best to solve them. I'll send you guys the Discord link in the description. You guys can check it out, and we can solve this together. Alright, we'll solve this together. Right. So let's do this. Right. Let's finish our identities. This will be our sort of homework. Right? Your only homework. It's a nice little homework for you guys to do. Okay, if you guys can do it, nice. If you can't, then it's fine. I'll show the solution in part 2, which I'll make tomorrow, most probably, not today. So let's do identities. Before I begin, I think it's time I list out every single identity, because or else it can get really sticky. Alright, so let's break it down into 2 types of identities. Alright, we have, I'll break it down with the non-square identities and the square identities. So non-square identities are the basic ones like tan theta being sine theta, cosine. Then the inverse ones, cotangent, cosecant. What did I miss? Oh yeah, secant. This being 1 over tan. This being 1 over sine. This being 1 over cosine. The square side, we have a few special ones. We have, first one is sine square plus cosine square is equals to 1. So you can define cosine square as 1 minus sine square, and you can define sine square as 1 minus cosine square. There's a few more, a lot more than this, of course. The next ones which I want you to know is, find it. Alright, this one. There is tan square, which is secant square minus 1. And another thing I want you to know, if in that case, then secant square is just tan square plus 1. All that matters is if you know one of these, so it's just rearrangement of that equation. It's not a big deal. Then we have cotangent square, which is cosecant square minus 1, I think. Could be wrong though. I want to check this out real quick in a moment, but for now, let's just have these in our minds. We mostly don't need these secant squares and tan squares most of the time. Rarely we need them. Mostly it's the other ones. So let's do a few basic identities. Hey, let's do this one. Alright, let's do this one. This one is secant theta minus tan theta by cosecant theta. This is equals to cosine theta. I'm gonna leave it here for you guys to solve, and I'll solve it in 3, 2, 1. First, let's break stuff down into simple forms. Secant is just 1 over cosine, right? Tangent is sine theta by cosine theta. Cosecant is just 1 over sine theta. Now this will go on top and become a reciprocal. So 1 minus cos theta minus sine square theta cosine theta. Now what we're left with is, when you add them together, is cosine theta 1 minus sine squared theta. We know 1 minus sine squared theta is cosine squared theta. We have it here in the list, right here. So that is exactly that. So you'll have cosine squared theta by cosine theta cancelled. That's why it's cosine theta. Oh yeah, one more thing I want you to remember to write LHS. LH. It's the left hand side. You start with the complicated side and work your way to the easy side. Hence, it goes to RHS, and that's it. See, cosine theta, cosine theta. It's proved. Very basic, very simple, very nice. Right, let's do another one. Let's do this one. Cosec. Oh, it's a weird looking cosecant. Fix it. So, cosecant theta minus cotangent theta divided by sine of theta is equals to 1 by 1 plus cosine of theta. Right, so again, we break stuff into simple forms. So we have this top one, cosecant. That is just 1 over sine theta minus cotangent. We can actually directly write this as cosine theta by sine theta by sine theta. Oh, LHS. I keep forgetting this. This is an important thing. Please write that. So the top becomes 1 minus cosine theta by sine theta divided by sine theta. Remember, this very important thing. This is like big division. Oh, what's a weird little division? This is like bigger division. So you want to remember this is being divided. A little mistake a lot of people think is that it's sine by sine. It's not. It's sine theta being divided by this. So I recommend just putting this whole thing in the bracket to make things much more easier. So there's like an invisible 1 down here. So this becomes reciprocal. So it's 1 minus, oh, that's not how you write it. My absolute apologies. 1 minus cosine of theta. Bottom is just sine of theta. And this is sine squared theta, because when this becomes reciprocal, another step I should have shown, I think I should show it if you're confused on how it's sine squared theta, is that it becomes 1 by sine theta. Right? So this results in 1 minus cosine theta by sine squared theta. Sine squared theta is, if we have it written here, I think, in this chart. I'll find it. There it is. Let me just plot this. I'm gonna have this posted like this. That's fine. Control C. Let's just make it here. Let's just put this right here. There we go. Cool. So we see that sine squared theta, we have it right here. Oh, sorry, it's right. It's down here. My bad. Is 1 minus cosine squared theta. So we write this as 1 minus. So we first top, right? 1 minus cosine theta. Bottom. 1 minus cosine squared theta. You may have noticed this is the a squared minus b squared formula. If you're confused how, 1 square is just 1. So a squared, this is a This is b, a squared minus b squared formula. If you don't know what that expands to, it expands to a plus b and a minus b. So we have the bottom, so the bottom will have 1 minus cosine theta, bottom will have 1 plus cosine of theta multiplied with 1 minus cosine of theta. Here, this one and this one cancels out, leaving us with 1 by 1 plus cosine of theta, which is equals to our right-hand side, RHS, RHS. Hence, proved. Check the top for, here it is. So, if you have one proof, I can just write down at the bottom. There it is. It's proved. Same thing. So hence proof. Nice. So that's basic identities, right? So we're gonna work on more identities for later. I'll make the Discord server. I will send the link. But this is what I want you to do. This is your challenge, right? Secant 2 theta minus tan 2 theta by cosecant 2 theta equals to root 3 by 2. The range being 0 theta to 180. So that's it for today. See you later. Bye bye. And let's get that A star.